to try these two problems, and then we'll go over it. Howdy. Yeah. Howdy. All right, let's go over. So for the line AC shown below, B is on AC. The length of AB is 12. The length of BC is 20. What is the distance in centimeters between C and the midpoint? What? Anybody have an idea how to do this? What do you think? What should I do? Oh, hold on. You're right that it would be 6 here, but we want to find between C and the midpoint of AB. Okay, hold on. Sorry. No, you just weren't done yet. This is 6. Okay, so then how do I find the distance from here to here? I did this one wrong. I just realized that as I was explaining it, that I did it wrong. I thought C was the midpoint of AC, but it's the midpoint of AB. I am a hooligan. So that's Mr. Lake. Always, you just had 20 and 6. Good job. Whoops. That's the key. I guess the key to this problem is really just reading the instructions carefully. Okay, which of the following is a factored form of x squared minus 5x plus 6? Tristan, what do you think? What's the factored form of x squared minus 5x plus 6?
I think that it's. I think that is A.
I think you're right.
I think I'm right.
Because -3 times -2 is +6, and -3 plus -2 is -5.
I mean,
Look at that.
again, I'm a genius.
Questions on the bell work? Okay, today in class, we'll see if we can get all this done. I don't know. Recognize and evaluate exponential functions with bases. That's not too bad. Graphing, that's just calculator work. Recognize, evaluate, and graph exponential functions with base. Again, that's just calculator work. Using exponential functions to model and solve real life problems. I don't think this is that bad of a class. I don't think it's too difficult. It is kind of a lot. All right, first thing, what is an exponential function? An exponential function is when you have a base that is a constant or really any real number, and then your variable is the power. Note that a has to be a positive number. A cannot be equal to 1 because 1 to any power is still 1. And then x is your variable, which will represent any real number. Negative infinity to infinity. Boom, 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 boom. Questions about that? Okay, first thing you're going to do with the exponential function then is just to evaluate it for different values. So here are 3 exponential functions, f, g, and h. Tell me what is the value of f when x is -3.1. What's the value of g when x is pi? What's the value of h when x is 3/2? You will do this in a calculator. Round your answer to the 3rd decimal place. I will give you 3 minutes. One of the answers will shock you. All right, you should have gotten that the answers are 0.117, 0.113, and then 1.158. Yes. If you're looking at your paper and you said, Mr. Lake, I put 0.116, well, you silly goose, the fourth decimal is a 6, so you have to round up. Yay, silly goose. Questions about this? Are we okay? You just type it into your calculator, 2 to the negative 3.1 power. Or you can really just Google it, 2 to the negative 3.1. Oh. Yay? All right. Okay, so the next thing you have to do is graph exponential functions. Here are the parent functions for a to the x and a to the negative x. You will notice that a to the negative x is just a reflection over the y-axis of the original. As it said in the definition, the domain is all real numbers. X can be anything from negative infinity to infinity. Your range will always be 0 to infinity, because if you take a positive number and you raise it to a power, it will stay positive, right? No matter what power you raise it to, no matter how many times you multiply it by itself, a positive number times a positive number is positive. This one has a y-intercept of 1, but really the y-intercept should be whatever your a value is. No, just kidding. It'll always be 1. Just kidding. If you have a to the positive x, then it's going to be increasing the whole negative infinity to infinity. It'll be going up as you go to the right. And if you get a to the negative x, that'll decrease. It'll always go down from negative infinity to infinity. The x-axis is a horizontal asymptote for both of these, such that as x, a to the x approaches 0, x will go to negative infinity, or over here, positive infinity. And it is continuous. There's no vertical asymptotes, no removable discontinuities, no jump discontinuities. It's nice, smooth, and connected throughout its entire graph. Yay? Questions on this slide? Okay, so then what you're going to do is either using the parent function or making a t-table, or to be honest, best option here, using a graphing calculator, graph each of these. 2 to the x, 4 to the negative x, and 4x plus 2. Give you 3 minutes. That's the next thing you're going to be asked to do on the old website. I think it's like multiple choice, pick the graph shown by the function. Thinking about implementing a policy where you can't get a lower homework grade than your test grade. You know what I mean? So like if you got a 90% on your test, then the lowest you can get on any assignment is a 9 out of 10. I like the theory of it, right? Because homework's there to practice so you can learn the test. And so if you got that high score on the test, there's no reason your practice grade should be worse than that. Right? You showed me that you've learned the material.
So what did you do the test? Get a good grade.
That's the problem. That's a problem, Ian. I mean, ideally speaking, I know there's some people, the homework is there to practice. And for there is a small group of people that are like, I could get an A on the test without practicing at all. You just showed me it once and I got it. I don't need to practice. And so for those people, it would be a real boost to their grade. My worry is if it would demotivate people to do the homework and then they would do worse on, because some people who need practice might skip it then. You know what I'm saying? I worry it might demotivate people from doing the homework. Maybe we'll try it for a unit. You could be like my test case this class. Because you all are a bunch of responsible individuals, right? Yeah. This is good. That's what I'm saying. I worry that'll demotivate people to do the homework. Then
I'm
again,
telling you right now, it will demotivate me.
all right. Maybe I'll just do it and not tell people.
Yeah. Don't tell us.
I'll just do it and just not tell anybody. Maybe I'll just do it at the end of the semester, go back and change everyone's homework, so it can't be lower than the test. But I'm not gonna tell you that, and I'm not gonna do it. That way it doesn't affect your motivation at all, but also allows a theory. That's a great idea. So I'm not going to do that. Well, now I can do it for every class but this one, because now you all know. So now this is the reverse test case. You're now my constant group and the rest of them are my test case. Well, we kind of walked ourselves. Okay, so how to do this? Well, easy peasy lemon squeezy. You just go to the old desibos.com, you type in the old grapharoni, and you just plug it in some points. Or, I mean, you can just type this into your calculator for like 5 points. And so like 2 to the 0 is 1. 2 to the first is 2. 2 squared is 4. 2 to the -1 is the same as 1 over 2 to the first. Do you remember that exponent rule? Negative exponents take your number and put it in the denominator of a fraction under 1. So 2 to the -1 would be a half. 2 to the -2 would be 1 over 2 squared, or a fourth. To be honest, it's actually probably easier just to do this by hand than it is to like do Desmos and then plot the right points. That's 2 to the x. So 4 to the -x. Well, again, 4 to the 0 is easy. Anything to the 0 power is 1. 4 to the first, or to when x is -1, when x is 1, you would have 4 to the -1, which again is 1 over 4. So it'll be like right there. When x is +2, you have 4 over -2, or 1 over 16, which would be right there. And you can see why as x gets bigger, this just gets closer and closer to 0, but it would never actually be 0, because it's always 1 over a really big number. But there's always that 1 in the numerator, never be 0. For our negative values, if you do 4 to the -1, well, that's just 4 to the first, and that's just 4. If you do 4 to the -2, and that's just 4 squared, and that's 16, which is like way up there. So then you'll notice as your A gets bigger, it gets a lot sharper, your graph. But also you could just get that same thing from the old Desmos, 4 to the -x, right there, and then you can see a -1. The answer is 4. Or if you type in your TI-84, you can hit second graph and it'll pull up a table doing all this. All right, and again, for this one, you can either just plug in values. If you plug in 0, 4 to the 0 is 1 plus 3 is 4. 4 to the first would be 4 plus 3 is 7. 4 to the second would be 16 plus 3 is 19, which is way up there. If you do -1, 4 to the -1 plus 3 is 1/4 plus 3, or 3 1/4. Maybe right there. And then 4 to the -2 plus 3 would be 1/16 plus 3, or 3 1/16. Which would be right there. So this one will have a horizontal asymptote at y equals 3. Do you see that? Because if you added 3 or moved the graph up 3, the horizontal asymptote will move from the x-axis to y equals 3. This line right here is your new horizontal asymptote. Because your answer will always be some really tiny number plus 3. Thank you. Questions about that one? Do you think you could do that in a Desmos or TI-84 or by just plugging in x values? I think on WebAssign, you're asked to like match equations with graphs and you click the right multiple choice, but I don't think you actually have to go in and input any like we had to do for quadratics. I don't think. If you do, it'll just be 2 points that you need to do. Yay? All right, we're just cooking along here. Okay, this slide is optional, but you notice that to do that math, there was a lot of exponent rules that we had to do. If you have forgotten your exponent rules, they're right here for you. Most important ones that mess people up is number 3 and number 4. If you take a number to a negative power, you put that value in the denominator of a fraction under 1 to the positive power. And anything to the 0 power is 1. But the rest of these, again, are stuff you used last year. A to the x times a to the y is a to the x plus y. If you divide two bases of the same, or two values of the same base, you subtract the powers. You can distribute powers through parentheses. A power to a power means you multiply the powers. You can distribute again. This is just a distribute property again. And then the absolute value of a squared is just a squared. Because any number squared is positive. That, of course, assumes that a is not imaginary. Jay, do you remember these from last year? To be honest, you did these in Algebra 1 too. So you've seen this Algebra 1 and this year. This is your 3rd year of seeing it. Anybody need more time on this slide? Okay. All right, here's some, I think this might be new for you. Have you used E before? E is an irrational number. It is an infinitely long, non-repeating decimal. Like pi, it represents the number 2.718281828, continuing on forever, not repeating. What it represents is an exponential function where 1 plus 1 over x to the x power is set to infinity, which, if you recognize this, this is your compound interest formula. And if you compound it continuously, or every millisecond of every day, so as x gets crazy large, it approaches an actual number, 2.71828, 18281, and then continues forever. This is a graph of it. So don't let E mess you up. It's just a number. It's just 2.72 or 2.718. Questions about this slide? I'm either doing a great job or I've lost you. Let's see. This is what you have to do on your, again, this is the first thing that you're going to have to do on WebAssign. So here's your exponential function, f of x equals e to the x. Tell me what's f of -2 and what's f of 2/3. 1 minute this time. Oh no, this has sound. Oh, this is obnoxious. $26 seconds left. Have you pushed like 6 buttons in your calculator? If not, you have 15 seconds left to do it. All right, as the first thing that you'll have to do, if you go to your calculator, you're just going to do e to the -2. Should get 0.135. And if you do e to the 2/3 power, you should get 1.948. Yay. So you can do that on WebAssign? Your homework? All right. So again, that's f of -2 would be e to the -2, which is about 0.135, and f of 2/3 is about e to the 2/3, which is about 1.948. Okay. All right. So what I get the most questions about on the WebAssign is actually the application questions for this one. And it really comes down to just, do you have the formulas or not? So the most common application for exponential functions is interest. So if you have a balance of A in an account, oh, well, hold on. What do you got? I did not see anything. If I see it, I'll let you know. All right. So if you put P principal in an account to start it out, and you want to find the amount A that you have after a certain number of T years, then what you need to do is take the annual interest rate, R, in decimal form. That's really important. So if your interest rate is 2% a year, that's 0.02 as a decimal. You need to use the decimal in the formula or you will get a crazy answer. Then you can use the following formulas to find that about A, depending on how it's compounded. If it's compounded n number of times a year, then you use this formula. And for most of you, for your real life, you'll usually deal with interest that's compounded every month. So if you have like a savings account, or if your checking account generates interest, or if you owe somebody money, generally that will be compounded where n is 12. At the end of every month, they take the principal and apply your interest. For certain situations, however, it'll be continuously compounded. So again, that's every millisecond of every second of every day for the whole year. It's always compounding interest. In which case, 1 plus r over n to the nt reduces to the number e, because as x approaches infinity, this value will approach e. And so you'll just take your principal times e to the RT, or PERT. Appert. Appert. If you're thinking, you know, how am I going to remember Appert? The easiest way is to name your child after that, Appert, and then you'll know it for the pre-calculus tests. Or a cat or a dog, I guess, turtle. If you have a pet, go home and change their name to Appert, and then you'll remember this formula. Forever, really. What are you not going to use continuously compounding interest? That's right. So b squared minus 4ac all over 2a. And for the most time, you'll just call them negative b.
Yeah.
But if they're in trouble, you'll be like negative b plus minus squared root b squared minus 4ac all over 2a. You get your butt in here. Is this a turtle?
This is a bird.
A bird?
I don't think
Your
turtle
turtle
flies.
flies
Yeah, my turtle flies.
into windows?
In the window.
Well, you should tell your bird not to do that. I bet you
I
your
don't think
bird
it's
would not
like-
fly into windows if its name was Appert.
Probably not, so it would be really
No,
smart.
That's right. All right, let's have you try it. So let's say you have $9,000. You want to invest it in an account that generates 2.5% interest a year. Tell me how much money you would have after 5 years if the interest is compounded annually, quarterly, or continuously. And continuously. Tell me the answer for all three. This is real deal stuff. To be honest, your actual real deal stuff is probably more difficult than this. Because usually you want to do the reverse where you're like, I want to have $10,000, right, 3 years from now so that I can buy something. How much do I have to save to get that? And that's an even tougher problem. Definitely still doable by the same formulas. And I'll give you a hint after a minute. This problem will be on the quiz, by the way. Whenever we take a quiz, this will be on it. All right, here's a hint. If you are stuck, first thing you need to tell me is what is P, what is R, and what is T. That is the same for A, B, and C. All have those in common. Then for A, you will need to tell me what's N. For B, what's N. And then for C, you don't have an N. There is no N value for C. For C, you have to use the other formula. One more hint. For A, n should be 1. It's compounded once a year, annually. For B, n should be 4. It's compounded quarterly, so that would be 4 times a year. It'd be fun. We should call on somebody. We should call on somebody. I'll give you 30 more seconds just to look at a neighbor's paper and steal the answer that they wrote down before I call on somebody. I say steal, get helpful advice on the answer. Tristan. Yes. 3-3. The dice have decided. Tristan, what is the P principal?
9,000?
9,000.
Actually, I can do R and T too.
Have at it.
Yeah.
What's R?
R is 0.025.
Hey, good job. All right, what's T?
T is 5.
Yay. All right, so I'll do the rest. Thanks, Tristan.
Yeah.
All right, first problem then, we need to write in the first formula. So the formula for these two is P1 plus R over N to the NT. So for annually, it would be 9,000. 1 plus 0.025 over 1 to the 1 times 5 power. Which if you type into the old calculator, you find that you have $10,182.67. So basically, over 5 years, you made an additional 1,000, almost $200. All right, if you did quarterly, very similar formula. The only difference is the N value is different from quarterly because you do it 4 times a year instead of just once a year. So then it's 9,000, 1 plus 0.025 divided by 4 to the 4 times 5 power. So that is $10,194.37. So if you compound it quarterly rather than annually, you end up making $6 more, which can buy, like, I don't know, your lunch. Right? All right, if you did it continuously, that's a different formula. Continuously is Appert. So then it would be 9,000 e to the 0.025 times 5, which is $10,198.37. So if you compare annually to continuously, you make actually $16 more. And now you could take you and a buddy out to lunch. You make a friend, right? And then that friend can then start giving you things like, trips to the airport, help you move. And now you're saving real dollars. right? You're saving cab fare to the airport. Now you got this friend who took out to lunch, to like Arby's or something. Now they owe you. No? All right, fine.
That's how you do it. The only thing Arby's has is the curly fries.
I hear they have the meats.
Their curly fries are fire, so like the rest of it, it's not.
The curly
It's
fries are
dirty,
good.
it's just dirty.
Yeah,
It's not, like the fries are really good.
the
That's-
curly fries are really good. I used to eat, back when I wasn't a vegetarian, the roast beef and cheddar. I could eat like 3 of those.
That's gross.
I know, it was so good. It was so awful.
You probably eat a lot of those.
The
Yeah,
only thing I like there is the chicken sandwich.
the Arby's sauce.
Arby's sauce is literally just ketchup.
One of the biggest arguments in my relationship with my wife was realizing that she never did the Arby's sauce at Arby's.
No, olive oil.
What do you got?
Just to make it red.
I guess. You're gonna miss out on the Arby's sauce.
I miss Arby's.
Yeah. All right, happy with annual interest? Well, let's bring it back. Okay, so I know what you're thinking. Mr. Like, when am I really ever gonna use a savings account? Can you give me something that I'll really use in my job? All right, so let's say you have a mass of radioactive strontium whose half-life is 29 years, and you want to know how much are you gonna have, or sorry, the quantity present is given to you in this formula, and you want to know how much strontium do you actually have? That's a legitimate question.
Especially the super strong.
You don't want to misplace how much strontium you have. That could be dangerous. Strontium. I'll give you 3 minutes to this problem. You really just need 30 seconds. This is also on WebAssign, I believe. The answer will shock you. You don't even need a calculator to do this problem. This is a real deal, because if you get the wrong answer here and you think you have a certain amount of strontium, when you really have a different amount of strontium, that's a lot of radioactivity. That could be difference there. I mean, if you're trying to become Spider-Man or something, right, and you want to have the right amount of strontium, and it turns out you don't have that, then you might become like Venom or something.
You ever just-
That's
you ever
the
just
difference.
wanted to become Spider-Man?
Yeah, I mean, yeah,
I mean, yeah, but like, you ever just buy strontium?
to try to become
With-
Spider-Man,
yeah,
they
try
have
to-
banned me from buying strontium.
If you're not doing that, you're wrong.
They said you cannot buy any more strontium than I already have.
They said that's you?
Yeah, they did. Then they came and took the rest of my strontium.
Oh, man, not your strontium.
I know,
She was over the legal limit.
yeah. They found out I was buying strontium from multiple different sources and then like hoarding it. It was kind of a big deal.
They probably
If
thought
you
was
look
like
up in the
100%.
news, Kansas man buys too much strontium. It's me.
Like,
It's
they were
2000,
saying it, they were supposed to be a
2018.
Florida man, but then it's like
No.
Kansas, you know? It would be silly. Yeah.
Also, as a disclaimer, I probably don't need to say, but buying strontium and applying radioactivity to yourself will not turn you into Spider-Man. Don't do that
I
at
don't
home.
think you're right. I think they would definitely turn you into it. You ever just try to get bit by the most poisonous spider in the world? Just to become Spider-Man?
That would be fine to be bitten by a poisonous spider,
But it's better if you do.
It's a venomous.
because poison means if I eat it, then I die.
But like if it.
Venom,
bites you, it's-
venomous is when it bites me and then I die. The answer was 10 grams. If you plug in 0 for t, which is all this is telling you to do, you don't even need to type that to your calculator. What's a half to the 0 power? 1. What's 10 times 1? It's 10 grams. So don't let that problem on WebAssign spook you. I think there's another one that it gives it another context like that, where it's just asking you to plug in a number. Don't let them spook you. All right, that's fine. Hey, we did it. I didn't think we were going to do it, but we did it. There's just a lot of slides. We just went through 12 slides.